Hello, everybody. All right, we are starting the topic called derivative. And so, what we're going to be doing, I'm going to be introducing to you interpretation of the derivative, considering the derivative as a function, and consider some properties of the derivative. So, hopefully, by the time we're done with derivatives, you'll have a collection of basic derivative formulas and rules that will be used throughout the study of calculus. So, where we typically start is we typically start with what's called a tangent problem. And when we're doing this, we basically typically when we do tangent problems, we do them on a XY axis, and they're usually tangent to something like a specific point on the curve or whatever. What we're doing here is we're going to be looking at a variety of different functions, and we're going to be able to come up with a tangent line equation based off of specific points, and then find the slope of that tangent line for any point on that specific function we're looking at. Just to give you a little background, calculus itself did grow out of four major problems in European mathematics. One of the problems was a tangent problem. Another one is the velocity and acceleration problem. Another one is the minimum and maximum problem. And another one is the area problem. Throughout each of those four, each problem basically involved the notation of a limit. And so that is why when we start calculus, we usually start it with the limit itself. And so when we start talking about the derivatives, we start talking about tangents. So let's talk about what we're actually going to be focusing on today. What we're going to do is we're going to find equations for tangent lines in the normal line. We're going to look at rate of change of a function, the average velocity, instantaneous velocity, and the derivative of a function at a specific number. So that's kind of the order that we're going to go in this video. So let's jump right into it. If you do not have these in your notes somewhere, you need to make sure you have these notes, and you actually need to commit these to memories. So these are some of those things that you're going to be expected to know, especially when it comes up to the AP exam time. You need to know these. You need to make sure you remember these and everything else. So make sure you have these somewhere. That's why you have the little remember thing over here and the little string tied around your finger, because all these are really important. I hit this one a lot. I did not talk about this one as much. This one it's still important to know, but just not as popular. So just put this in your notes somewhere, put on a flashcard, whatever, so that way when it comes time to remember these specific limits or whatever, you'll have access to those. So we're going to start off with the difference quotient. Now this is a pre-calc concept. We'd start talking about this in pre-calculus. But the difference quotient is what people would consider a magical tool that gives us the slope of a curve at any single point. And so with the calculus portion behind it is we usually, when we talk about the difference quotient, we usually talk about in terms of running the limit of h to 0. Because what's going to happen is when you use a difference quotient on a function, there's going to be a point to where you're going to get down to a very specific point, and then all your h's will be able to cancel out. So then you run this limit h to 0, and then all the h's will go away, and then you're left with this nice pretty little function that has no h's in it, but has everything in terms of x, which is what we started off with. And what you're doing here is you're generating a slope function is what you're doing for that whole entire problem. There is a note. So when we use a difference quotient, so let me go back. So when we use a difference quotient, if you were to basically plug in 0 for all these specific parts of it, what would wind up happening is that you would wind up with a 0 over 0. And we can't have that. And so you're going to have to do a little bit of algebra behind everything so you can cancel out your h's, because when you're looking at the difference quotient and you're looking at it in terms of limits, all your h's should go away when you run that limit to 0. So when you're focusing on the actual slope function, then you should not have any h's in it at all. So how do we do this? This is the way, so this is until you get comfortable with it. Now, once you get comfortable with it, then you can start making changes on your own. But this is just my way of recommending to you how you should approach this problem. So the first one, obviously, identify the f of x. So they're going to give you a problem. So there, f of x defined. The next piece, though, this is usually where people make a lot of their mistakes. You need to take your f of x function and evaluate it for x plus h. And then you're going to put the numerator together. The numerator is the f of x plus h minus f of x. So you're going to take 2 and subtract it from 1. And then you're going to clean up that numerator. And when you clean up that numerator, everything that does not have an h in it should cancel out. So that way, when you put number 3, when you put the difference quotient back together, all your h's will eventually be able to cancel out. And then, depending on what the question is, you're going to evaluate. So let's look at this. I want to know what's the slope of the parabola f of x equals 10 minus x squared. Now notice it didn't give you a point or anything. It just asked for the slope. So what you're going to have to do is you're going to have to use that difference quotient. And one of the ways to be able to approach the difference quotient is to break it down in pieces. I would not, until you get comfortable with it, I would not recommend doing the difference quotient all in one big swoop. So the first thing you're going to want to do is you're going to want to evaluate f of x plus h. So this means I'm going to take my 10 minus, not x squared, to be x plus h squared. And I'm going to clean this up. So 10 minus x squared plus 2xh plus h squared. And then I'm going to distribute my negative. Minus x squared minus 2xh minus h squared. Okay? Then the second thing we're going to do is we're going to then take that and we're going to say f of x plus h minus f of x. So what I'm going to do is I'm going to take this piece right here. We're going to copy this. And then I'm going to go ahead and now I'm going to paste that. Doop. I'm going to put that right here. And then I'm going to say, okay, but then I want to go minus 10 minus x squared. So I'm going to clean this up. So I've got 10 minus x squared minus 2xh minus h squared minus 10 plus x squared. So now, if you have done everything correctly, this whole back piece back here should cancel with the front. So that x squared cancels with that x squared. That 10 cancels with that 10. And if done correctly, you are left with everything that has at least one h in it. So then we go f of x plus h minus f of x all over h. So that means I'm going to take this piece right here. So I'm going to take that negative 2xh minus h squared. And then I'm going to divide that by h. I'm going to clean this up, and I wind up with negative 2x minus h. So what I do from here is I say, okay, the limit as x approaches 0, not x, I lied to you, as h approaches 0, of negative 2x minus h is negative 2x. And this piece here, that is your slope equation for this specific parabola. Okay? So what you have just found, this is your slope equation. So this will generate a slope at each specific point on that specific parabola. And it doesn't matter where you're at. You'll plug in whatever x value is, and it'll tell you the slope. So you can draw these things. It's called a slope field. And we'll learn about that later on. But you're going to draw a slope field to be able to create what the actual picture should look like. Okay? So now, remember this, negative 2x. So then what is the slope of the parabola f of x minus 10, or f of x equals 10 minus x squared at x minus 3? So we know that our slope formula was negative 2x. And so they gave me a number here. So my slope would be negative 2 times 3, which gives me negative 6. So when my x is 3, the slope at that x value is negative 6. And so how do you know? What are we doing here? And, why does that make sense? So let's take a look at this whole thing here. If I come over here and say, okay, so I've got 10 minus x squared, okay? And I graph that. If I take a look, and I hit trace and I hit 3, I am over here on that specific piece right there. And so what's happening here is I'm finding the slope. So when I get to here, the way that this parabola is changing at a rate of negative 2x. So each point along this line is changing at a rate of negative 2x. But what's specifically happening is when I get to x equals 3, I am specifically changing at a speed of negative 6. So I am dropping at a speed of negative 6 is basically what it's saying. So I'm going a little bit faster and a little bit faster, the further and further down I go. Okay. So that's what this is saying. This is saying that my parabola is changing at a rate of negative 6 to 1. Because if you think about this, because, slope is rise over run, negative 6 is actually the same thing as negative 6 over a positive 1. So I'm changing at a rate of negative 6 to 1. So I'm dropping down and running 1. I'm dropping 6 and running 1 at that point. Okay. So now, this is just kind of talking about what I just specifically said. Your slope is dy dx, the change in y over the change in x. And that is what all this is talking about. You will see the difference quotient with a delta x in it. You'll see it with a c in it. You'll see it with an h in it. That all means the same thing. It all means y2 minus y1 over x2 minus x1. It all means that same thing. So when you're looking at the difference quotient, yeah, I know it looks big and ugly. It does. But don't be scared of it because it's just slope. All right? So what we're going to do is we're going to use a difference quotient to verify that dy dx equals 2 if y is equal to 2x minus 1. So this is what I want you to do. I want you to take a few moments, hit the pause button, and then literally find the slope. So use your difference quotient here and plug this in and see if you get this answer here back, which is exactly what you should find. When you do the difference quotient in this piece right here, you should get the number 2 as your dy dx. So take a few moments, hit the pause button, and go through that, all right? So hit the pause button now. All right, welcome back. Let's see how you did. So f of x plus h. That is 2 times x plus h minus 1. So we have 2x plus 2h minus 1. I so wrote x exactly when I said h. Let's try that one again. So then we have f of x plus h minus f of x. So that is 2x plus 2h minus 1 minus 2x minus 1. That's 2x plus 2h minus 1 minus 2x plus 1. Then that and that are canceling, and then that and that are canceling. So then I have f of x plus h minus f of x all over h. So that gives me 2h over h. 2h over h. Those cancel, and that leaves me with just a 2. And so remember that this here is the same thing as dy dx. So we have verified that what we just did, that the dy dx of 2 is actually the slope for this, this specific function. Okay. All right. So difference quotient hopefully wasn't too bad for you. So let's actually look at slope of tangent and secant lines. So before defining a tangent line, we need to look at the slope, obviously, because in order to find a tangent line, you need to make sure we actually have a slope. Because what's going to happen is when they give you a tangent line, or they're asking you to find a tangent line, they're going to give you a function and a point. So the most important thing is to actually find the slope of the tangent line, because they've already given you the point that you're going to be focusing on, okay? So to refresh your memory on a tangent line is just going to touch your graph at one specific point. It is not going to cut the graph. It's not going to have 2 or 3 different places. It's just going to cut it at one specific point. Now, you have what's called a secant line and a tangent line. And I want you to take a notice here. If you take a notice and look at both of them, the slope of a secant line is going to be this piece right here. And then the slope of a tangent line is going to be this piece right here. The main difference between the two is not the formula, it's this piece right here. Because what's going to wind up happening is when you run a tangent line, you're only going to have one point. And so you need to be able to come over here and run it up to that point so you can start canceling things out so you can actually get that actual slope piece. Your secant line is just what you've done in the past. You're just finding slope from one point to the next. So secant lines are extremely easy. You're going to have 2 points. You use your slope, you put it in a point slope form, and you're done. Tangent line, you have to do a little bit of limit work to it. So that's why we learn limits before we go into derivatives for that specific piece right here. So the other thing that you're going to also see is going to be specific notation. So we don't want to always write this, okay? We always don't want to have to write the word derivative. But what we do write is we write f prime. All right, so if I took this function here and I want to denote, and I wanted to note that I've got tangency, I've got a prime notation, we actually don't use that. We use the f prime. All right. So the f prime is what we're actually going to start focusing on and using more of. So that's going to be our new shorthand. So when we talk about derivative, we talk about slope, we talk about f prime. So yeah, I just kind of said that because we use it so frequently. So equation of a tangent line. So what's going to happen is they're going to give you a point. Okay, let me actually turn on the one. They're going to give you a point x, y. So, and then they're going to tell you to evaluate it at that point. So they're going to give you this equation over here that you're going to actually have to do. So you're going to have to use a difference quotient to find the slope formula for that. And then what's going to happen is then you're going to take that slope formula and evaluate it at this specific point right here, at that x value only. And then you're going to come over here and take that, put it in here along with the point that they gave you, and that was going to give you the equation of the tangent line. You're probably going, what? When we actually start doing problems, you're going to see exactly what I'm talking about. The normal line, because sometimes you're going to be asked to find the normal line as well. The normal line is extremely easy because you've done all the work up here. So up here, you've done all the work. The normal line is the easy piece because you take whatever this is, you flip and change the sign, and that becomes a slope. You use the same point, that becomes a new slope, and then you solve. The key for the normal line, and this was a Jeopardy question, it's always perpendicular to the tangent line. So that's the nice thing about the normal line. There's not extra work per se that you actually have to do. But I mean, it's extremely easy because you already have all the legwork and everything laid out for you. All right. So f prime of c. So if you ever wind up with a 0, okay, that means that the tangent line is a horizontal line. Horizontal line. So I will give you this note. So put this somewhere and highlight this. If you have an f prime of c equal to 0, that means you are on a turn point. You're on a min or a max somewhere. So that means you've got this graph over here and it's doing something like this. And that means you're either sitting here or you're sitting here. So if you ever wind up with that, that means you're sitting on a turn point. That's all that means, okay? Because that means you'll come over here with your tangent line and you'll just run it straight across just like that. Okay? So hopefully that's not going to be too bad. So let's start this. Given f of x equals 3x squared, find the slope of the secant line containing the points of this. Okay? So secant line is what? It's literally just doing slope. Okay? So we've got our delta y over delta x. And that equals 27 minus 12 over 3 minus 2. And that gives me a 15 over 1. Okay? So I have a slope. I'm going to use that point because I can. I can use the other point. Don't matter. And then I'm just going to plug it into my point slope formula, which, to refresh your memory, y minus y1 is equal to m times x minus x1. Okay? So I take my point, I take my slope, I'll just keep it in blue. And then, oops, that is not 15. That does not go there. Do not pay attention to that. Let's try that again. So y minus 12 is equal to 15 times x minus 2. And now just clean it up and solve for y. 15x minus 30. So y is equal to 15x minus 18. Now, here is something really cool and really nice for you to know. If you are on your AP exam, unless they specifically say solve for y, you can stop right there. You have done exactly what they wanted you to do. That is an equation of a line. That is point slope form. You are done. So you don't have to go any further than what you have written right here. If you want to go down to here, even though it doesn't tell you to. If you decide to, here is the problem. If you distribute incorrectly and get a sign error, that could really mess you up because you've done everything perfectly beautifully here. And then let's say this is you weren't paying attention and you wrote a positive 30 and then you move that over. And so this piece here is wrong. You have now missed the whole part of that problem. Okay. So on a free response question, if it asks for the equation of a line and if it does not tell you to put it in y equals form, stop right here. Do not go any further than that, okay? Don't turn it into y equals form. Just stop, all right? All right. Oh, I just did that. So I found the slope, and then I went over here. So here, let's just do this, just so you'll have it in your notes. Excuse me. See, I got ahead of myself. I got so excited about doing this. So we'll cut that. And then we'll come over here and we will paste it. And there you go. So there's my secant line. All right. Well, that was easy. So let's go to the next part. Now, given f of x is equal to 3x squared, find the slope of the tangent line at that specific point. So now you don't have another point here. So you have to go and use your difference quotient. So we say f of x plus h minus f of x all over h. I'm going to do this in one big swoop so you can see what it looks like. So 3 times x plus h squared minus 3x squared all over h. So that's 3 times x squared plus 2xh plus h squared minus 3x squared all over h. So then I have 3x squared plus 2xh plus h squared minus 3x squared all over h. Man, a lot of work. Those two are canceling. 2xh plus h squared all over h. One dun dun. So I'm left with 2x plus h. So then I say my limit as h, not x, I was about to write x, as h approaches 0 of f of x plus h minus f of x all over h is 2x. Now I want to find the slope of that. So then I'm going to use this point right here. So then I say 2x. Well, that turns into 2, come on, 2 times negative 2. And that turns into negative 4. So my slope at negative 212 on this graph here is negative 4. Okay, so that's what this means. All right. So, and then if it asks you again for the equation, because it only asks you for the slope, there's your point. I'm sorry, there's your slope. There's your point. Use point slope form and find that equation. All right. So, I want you to take a few moments. I want you to hit the pause button. And I want you to find the secant line, the equation of the secant line, and then I want you to find the slope, and we'll go from there. Okay, so you're going to find the slope of the secant line, and then you're going to find the equation of the secant line, and then you're going to find the slope using that point right there of the tangent line. Okay, hit your pause button now. All right, welcome back. Let's see how you did. All right, so my delta y over my delta x is 27 minus a minus over 3 minus a minus. It's 35 over 5, which is 7 over 1. So my m is 7. I'm going to use this point here. So y minus 8 is equal to 7 times x minus 2. If you decided to solve for y, 7x minus 14. So my y is 7x minus 6. Okay. Again, free response questions, unless it tells you to solve for y, leave it in your point slope form. Now let's go to your tangent here. So if you did everything correctly, your slope formula should be 3x squared, which means when I plug in my negative 2, I get 3 and then negative 2 squared. That generates 3 times 4, so that generates a 12. So we got y plus 8 is equal to 12 times x plus 2. Again, I can stop, but if you did solve for y, you get that. So y is equal to 12x plus 16. Okay, either or, better be safe than sorry. So I would personally stop there, but again, if you choose to, you can. Okay. All right. Fun stuff, huh? Find the slope of the tangent line to the graph of f of x is equal to x squared at c is equal to negative 2. All right. So we're going to do something a little different on this one, just to show you there is a different way of doing it. So we're going to say f prime of negative 2, that's going to equal the limit as x approaches negative 2 of f of x minus f of negative 2 all over x minus a negative 2. So just focusing on this piece, we're only going to clean this up for right now until I get to the point where I can't do it anymore. So f of x is x squared minus f of negative 2. So I plug in negative 2 here. I'm going to get a 4 all over x plus 2. Okay, now notice if I plug in that negative 2 into here, I get a 0 over 0. So that tells me I can factor x plus 2, x minus 2, all over x plus 2. Notice that these are going to cancel. So what I'm really looking at is my limit as x approaches negative 2 of x minus 2. That will generate a negative 4. So when you're in a situation like this, and if it doesn't say difference quotient, and if you feel comfortable, this is another way you can actually approach it as well. So just kind of pick and choose, be specific, watch your questions, and they might tell you that you need to use a difference quotient or you need to use some other form of it. So just pay attention to that, okay? Find the equation of the tangent line to the graph of f of x equals x squared at c is equal to negative 2. Well, we just found that. So your f prime of negative 2, that is 4. So this is the same thing as slope. So now when I take this negative 2, I need a point. So when I take this -2 and I plug it into the x squared, I get a +4. So I have a point, I have a slope. So now I'm going to use, went back too far. I'm going to use my point slope form. Okay. So I'm going to say y minus 4 is equal to 4 4 minus x plus 2. And then, oh wait, it's not positive. It's +4. It's -4, isn't it? That's probably what y'all are yelling at. It's a -4. I was wondering why that didn't look right. There we go. That looks better. So y minus 4 is equal to -4x minus 8. Kick that 4 over. Y is equal to -4x minus 4. And there you go. All right. So I pulled that -4 over from the previous slide. I found my point, and then I plugged it into my point slope formula and got my line. Okay. So now, find the equation of, I got a typo, of the normal line to the graph of this at this point. So we already know that our tangent slope, and I am just batting 1,000 a day, aren't I? My tangent slope is -4. So my normal slope, would be flip it and change the sign. So it's going to be a +1/4. I'm going to still use the same point. So y minus 4 is equal to 1/4 x plus 2. So y minus 4 is equal to 1/4 x plus 1/2. And so then I wind up with this going to 8/2. So I'm going to move that over. So I get y is equal to 1/4 x plus 9/2. Okay. So hopefully it's pretty simple. Just a lot of slope formulas and stuff like that. So just again, don't make the mistake that I did, and make sure you bring the right slope with you or whatever else. So that is normal line, tangent, and secant line. All right, so let's talk about rate of change, because that is where the derivative really comes into play at. So why do we use rate of change? Everything in nature changes. So basically, when we want to describe natural processes mathematically, the ideas of rate and change we use a whole lot. Examples: climate change, changes in phases of the moons, changes in populations. So these are just different ways that we look at rate of change. So if you notice, the average rate of change looks really familiar. F of x minus f of c all over x minus c. That is your slope, because again, rate of change is slope. Rise over run, delta y, delta x. It's all slope. When we have an instant rate of change, that's our tangent. So our tangent line looks at an instant specific point. I have this specific point. I want to look at this specific point. I want to know what's the tangent line, because I want to know how am I doing at that specific point. So it's just like what we did on that last example here, is what this piece right here is looking at. Okay. As long as your limit exists, and that's going to be the key. So as long as that limit exists, the instantaneous rate of change will exist as well. So what we're going to do is we're going to find the rate of change for this function, f of x minus or equals x squared minus 5 at c equals 2, and then for any real number. So let's start here at c equals 2. So let's change a different color. Let's go purple. That looks good. We are going to go f prime of 2, that equals my limit as x approaches 2 of f of x minus f of 2, because that's what we're going to focus on, all over, what was it? I think it was x minus 2. So take a moment. You're going to say, well, what is f of 2? That is 2 squared minus 5, which gives me a negative 1. So then I come back over here. I'm just going to focus on this piece right here. So I have x squared minus 5 minus a negative 1 all over x minus 2. So minus a minus is a plus. So I have x squared minus 4 all over x minus 2. That gives me x plus 2, x minus 2 all over x minus 2. Those cancel. So my limit as x approaches 2 of x plus 2 is 4. Okay. So hopefully that wasn't too hard. You just went through it and I found that slope. So now, for any real number c, so notice this didn't give you any type of problem or like a specific number to focus on. So you're going to do the same exact thing. We're going to come over here and say, all right, well, fine. F of c, that is c squared minus 5. Okay. So my limit as x approaches c, okay, of f of x minus f of c all over x minus c. So we have x squared minus 5 minus c squared minus 5 all over x minus c. So then I have x squared minus c squared all over x minus c. That gives me x plus c, x minus c, all over x minus c. These cancel. So my limit as x approaches c of x plus c winds up being 2c. So that's going to be what's considered like your generic equation, basically, for that tangent line. All right. So don't be scared if it says any real number, you're getting a letter. That's okay. Okay. So that's not a big deal. That happens all the time in calculus. All right. We're going to move on to average velocity and instantaneous rate of change. So average velocity provides a physical example of an average rate of change. So consider an object moving along a horizontal line with a positive direction to the right, moving along a vertical line with a positive direction going upward. So horizontal, positive goes right, and vertical, positive goes up. This is going to be a word that you'll see. And motion along a line is referred to as rectilinear motion. Okay. The object's location at time equals 0 is called the initial position. So anytime you have t is equal to 0, t is equal to 0, that is your initial. Your initial position is usually marked as the origin on the line. So when we're dealing with this, t is equal to 0 starts at the origin. Now, that doesn't mean you can't go back and forth with it. It just means it starts at the origin. Okay? So average velocity. So average velocity is assigned distance, s. So we're talking about s here. From the origin at time t So we're looking at your initial time that they give you to the initial time that they tell you to stop. So in this case, when we talk about average velocity, it is not happening from the origin, it's happening from when they tell you. So they're telling you from, time 2 seconds to 5 seconds. So that T0 is 2 seconds and your T1 is 5 seconds. Okay? So that's going to be your average velocity. And again, man, this should look familiar. Okay? It's just your slope. That's all this is just slope. Okay? Instantaneous velocity travels at the time t, and the instantaneous velocity is defined as this piece right here, where you have f of t minus the time you're focusing on. So notice here, they're only going to give you a specific time. They're not going to tell you, well, you're going to start at this time or you're going to, whatever. They're just going to say, I just want to know, what is my instantaneous velocity? What is my velocity at 37 seconds? And then, so this will be this piece back here, the piece that you're actually focusing on. Really long word problem. So I'm going to give you a few moments to read over this. And we're actually going to walk through this problem here. So, hold on, I got a typo. Michael Callaghan, Pat Tillman Memorial Bridge. Man, that's a mouthful. Spanning the Colorado River, opened October 16th of 2010. Having a span of 1,900 feet, it is the longest arch bridge in the Western Hemisphere, and its roadway is 890 feet above the Colorado River. If a rock falls from the roadway, the function is, and so here's your function, s equals 16t squared. That gives a distance s in feet that the rock falls after t seconds for 0 to 7.458 seconds. So what this is saying, there's a couple of things you need to take note of here. First off, you have your function. Second off, we have as soon as the rock starts falling, it takes that long, basically kind of until it hits the ground. Okay. So we're going to use this information here, and we are going to start putting stuff together. So we're going to find the average velocity of the rock during this fall. And then we're going to find the velocity at t sub 0 is equal to 1 second after it begins falling. And then we're going to find the velocity t sub 0 at 7.4 seconds just right before it hits the river. And then we're just going to find the generic, so I can just plug in any number I want to find that velocity at any time. So let's start with the first one. Find the average velocity of the rock during its fall. So we've got a delta S over delta T. That equals f of 7.458 minus f of 0 all over 7.458 minus 0. Use your calculator for these ugly numbers. This would be a calculator type question here. Let me turn it on. It doesn't want to work. So what you do when you want to use your calculator for this is you come in here and you're going to go 16x squared. And then you're going to hit graph. All right, so I want to look at 7.458. That gives me, that 890, it said in the actual equation. F of 0, well, that's actually 0. And then minus 7.458 minus 0. So when I plug that into the calculator, I'm going to get somewhere around 119.335 feet per second. All right. Part B. Find the velocity at t sub 0 equals 1 second after it begins to fall. So what that means is that I've got, pick a different color. Go orange. Orange looks good. I'm going to do the same thing. I've got my velocity, just to let you know. Velocity is my limit as my delta t, my change in my x's, approaches 0, delta s over delta t. So that means, in this case, I have the limit as my t is equal to 1. That's going to wind up being f of t minus f of 1 all over t minus 1. So focusing on just this piece here. So that gives me 16t squared minus 16 all over t minus 1. I'm going to pull out that 16, and I'm going to be left with 16, and then t squared minus 1 all over t minus 1. See how pretty this works. Look at that. T plus 1, t minus 1, all over t minus 1. So then I say my limit as t approaches 1, because that's what I'm looking for. That's going to be of 16t plus 16 is equal to 32. Okay, but 32 is a naked number. So when they gave us a word problem, we need to make sure we have some context. So what is this 32? So how you actually physically answer this question is you say after, oops, it bounced back. You say after 1 second, the velocity of the rock is 32 feet per second. Okay, so this is actually how you answer your question. So when you have this question, you answer it basically in a sentence. Give me a one sentence answer and make sure it makes sense. Make sure you've hit all the topics and content of the specific question. Okay? Next part. So I'm going to give you a few seconds to answer this question on your own, and make sure you answer your question with a final sentence. Okay? So go ahead and hit your pause button now. All right, welcome back. So let's see how you did. So we've got, if you've done everything correctly, you should wind up with, where did it go? The limit as t approaches 7.4 of f of t minus f of 7.4 all over t minus 7.4. That should give you 236.8. So after 7.4 seconds, the velocity of the rock is 236.8 feet per second. All right. Part D, find the velocity at any time. So this one goes back to the one that we were talking about earlier, where you've got the limit as t approaches t sub 0. So we want an anytime one here. So it's f of t minus f of t sub 0 all over t minus t sub 0. So plug everything in that we know. Well, we know f of t is 16t squared minus 16t sub 0 squared all over t minus t sub 0. Pull out my 16. That leaves me with t squared minus t sub 0 squared all over t minus t sub 0. So that's 16 times t minus t sub 0, t plus t sub 0 all over t minus t sub 0. So now, if you go back to our limit here, we say the limit as t approaches t sub 0 of 16 t plus t sub 0. That gives me 32 t sub 0 feet per second. So, in words, because you got to get used to using your words, at t sub 0 seconds. So basically, you can put any time in there within that boundary that you want. The velocity of the rock is 32 t to 0 feet per second. All right. Fun stuff, fun stuff. Lots of fun stuff here. I know you're just as excited as I am, right? Uh-huh. All right. So, just to summarize everything, slope of a tangent line, rate of change of a function of velocity are all found by finding the same unit here. The common underlying idea of the mathematical concept the common underlying idea is a mathematical concept of the derivative. So everything that we're doing here is all about derivatives. It's the introduction to derivatives. We have three interpretations. Geometric. If y is equal to f of x, the derivative f prime c is the slope of the tangent line to the graph at f at that specific point. Rate of change. If y equals f of x, the derivative f prime of c is the rate of change of f at c. And then the physical piece, when the distance f or s at time of t is an object in a rectilinear motion is given by the function s is equal to f of t, the derivative f prime t sub 0 is the velocity. So physical is velocity, rate of change is rate of change, and geometric is slope. So to wrap things up, I'm going to give you one more practice problem. What I want you to do is I want you to find f prime of 2. So here's your f of x. That gives you 2x squared minus 3x minus 2. So I want you to go through here, and I want you to find the derivative at 2. All right. And I'm not going to have you pause the video. You and I are just going to work at the same time so you can kind of see what's happening here. All right. So let's just start this together. Let's just start it right now. And I'm not going to say anything while I'm writing this. I know that's going to be really hard for me, but I'm not going to say anything. All right. So if you did it correctly, you should have gotten 5. Now, if you're curious about what I did here, I factored this piece right here. All right, so if you need to brush up on your factoring skills, do that, because that is an expectation that you need to be aware of. You need to be able to factor this, and it should factor down into this piece here. Okay. All right, I know we have covered a lot, so, take a breath, go back and review parts of it just to wrap your mind around this. When you're ready, jump into Delta Math, do your Delta Math problems. And I should have something for homework-wise up for you in Google Classroom. So, hope everything is going well, and I will talk to everybody soon. TTFN. Ta-ta for now.